In this video, we'll be learning how to differentiate sums and differences of functions. Now, the idea here is, let's say we're given a function, f of x, which is equal to the sum of two functions, g of x and h of x. Then to differentiate this sum, all we need to do is to differentiate each of the two terms in the same way as we would if they were on their own. Meaning, the derivative f dash of x is equal to the derivative of g of x plus the derivative of h of x. And that's all. Let's see how this is done with a couple of examples. Let's say we had the function f of x is equal to x cubed plus x squared. Then in this case, to differentiate this, we would use the rule we just learned, and we could differentiate this function writing f dash of x is equal to the derivative of x cubed, which is 3x squared, plus the derivative of x squared, which is 2x. And that's the answer, or the result. We've just differentiated this function. Let's look at another example. Let's say we were given f of x is equal to x to the power of 5 plus ln of x. Well, once again, we're going to use the rule we learned, and to differentiate this function, we'll just differentiate each of the terms, x to the power of 5, followed by ln of x, as though they were on their own. So, the derivative f dash of x is equal to 5x to the power of 4 plus 1 over x. And that's how we differentiate the sum of two functions. Now, of course, we could have more than two terms. Let's say we had a function looking something like f of x equals to x to the power of 4 plus x to the power of 2 plus 3. Then once again, to differentiate this function, we differentiate each of the terms we see on the right-hand side. And we can write f dash of x is equal to 4x cubed plus 2x. And when we differentiate 3, remember this is a constant, it's equal to 0. So we stop here. We don't need to write plus 0. So the final answer here is f dash of x is equal to 4x cubed plus 2x. Now let's see how we differentiate the difference of two functions. Let's say we're given a function f of x, which is equal to a function g of x minus some other function h of x. Then in this case, the same rule is going to apply. We're going to differentiate each of those two functions on the right-hand side the usual way, and this will lead us to the derivative f dash of x is equal to g dash of x minus h dash of x. And so in a very similar way as what we saw for adding functions, we can use this for a couple of examples here. So let's say we have f of x equals to x to the power of 6 minus x squared. Then to differentiate this, we would use the rule we just learned, and write f dash of x is equal to 6x to the power of 5 minus 2x. Let's look at another example. Let's say we're given f of x is equal to x to the power of 4 minus ln of x. Then again, to differentiate this function, we just differentiate each of the two terms on the right in the usual way. And so we can go ahead and say that the derivative of this function is f dash of x, which is equal to 4x cubed minus 1 over x. Remember, the derivative of ln of x is 1 over x. And so this would be our final answer. F dash of x equals to 4x cubed minus 1 over x. Now this rule will still work if we have functions being added and subtracted. So for example, if we had f of x is equal to x to the power of 6 minus ln of x plus x cubed, then once again we would differentiate each of these functions on the right-hand side the usual way. And so we can say that the derivative f dash of x is equal to 6x to the power of 5 minus the derivative of ln of x, which is 1 over x, plus the derivative of x cubed, which is 3x squared. And we're done. That would be our final answer. And that is how you differentiate sums and differences of functions.